All right, the next one is 5.71. This is a rotor ride question where the wall spins around, you're sort of stuck in this can and it's going around and around and around, and then the floor drops out from under you, and you, as the stick figure here, are stuck to the wall and you can't fall. So if you think about a free body diagram, you have Fg is acting down. The force that prevents you from sliding down is going to be friction. And we know friction is mu Fn. The question is when you're stuck on the wall over here, what's providing the normal force? If you weren't going in a circle, there would be none and you'd just go down like that. But the fact that you're spinning means your centrifugal force is throwing you towards the outside, or your inertia is making you want to go in a straight line. So you're going to have this normal force which provides a centripetal force. That's with a P, not an F. So this mu Fn is really mu mv squared over r if you substitute like that. So forces are balanced, so FF and Fg are balanced. I don't know why that paused on me. So I'm not even going to write FF. I'm going to write mu mv squared over r equals mg. And they give you the radius. Now what's interesting in this one is they give you the rotational frequency. It's 0.5 revolutions per second. That's not in this equation anywhere. What you have to do is figure out how does that relate to v, or the tangential velocity. Tangential velocity is in meters per second. So 1 revolution is equal to 2 pi r. So I think if you plug in the radius there, your revs drop out and you get a certain number of meters per second. So you have to use the circumference to do that, which is not too bad a calculation. M's drop out. Whatever you get for this V up here that you're converting here, plug in down here. What is it asking for? What's the minimum coefficient of static friction? So yeah, plug that in there. G you have, R you have, solve for mu_s. And you're going to get an answer for mu_s. All right, the next part, people on this ride say they were pressed against the wall. Is there really an outward force pressing them against the wall? No, that's just silly. That's an imaginary force called the centrifugal force, F. That's imaginary or fictitious. All right, fictitious. I like that word better. Fictitious. It's really just inertia. So I don't know. Write an essay, 500 words or less. Good luck with that. I'm not going to do it. I'm done.